right, welcome to the Tech Transfer Podcast with video this time. Today we're talking about the LET joint, which is the laminate emergent torsional joint of BYU technology. I'm not an engineer, but Bennett, you are. What is the LET joint?
Yeah, so I'm going to read kind of the definition as explained in the patent that we have issued, and then I'll kind of give my own explanation. That way
perfect.
we get kind of the technical and a little less technical. So the laminate emergent torsional joint is a torsional joint assembly formed with, and this is very patent speak, so if you're not familiar with patents, it might seem a little foreign, but formed from a substantially planar material sheet, comprises a plurality of contiguous segments. The contiguous segments include at least two substantially parallel hinge segments, each being couplable to a loading structure, and at least a first connecting element connecting the hinge segments one to another, the connecting element extending substantially orthogonally to the hinge segments. So, right, basically Egyptian there, right? Not super easy to understand, but fundamentally, if I'm understanding it correctly, what it means is that from a laminar structure, so basically a flat sheet of material, you can introduce this hinged kind of segmentation of these joints into it, and that then gives the structure some flexibility in the direction that you desire, as well as stiffness depending on how you design these joints.
Okay. And what's special about it, it bends, and that's special because normally it's a material that wouldn't, and it's not a joint with a bunch of pieces, right?
Correct, yeah.
Okay.
And so typically if you wanted to have a piece of material, right, so we're sitting on a bunch of furniture, there's things in the background here that are employing that joint specifically to achieve the motion. If you were to do something similar with kind of traditional design methodology, what you would do is you would have pin joints, segments, different pieces. And so the chairs that we're sitting on are actually one piece of material. And because we're introducing this LET joint in specific places to achieve that desired motion, is one piece of material compared to your typical chair, right, which would have pins and joints and anything to keep it so that it could move.
Okay. And this came out of Larry Howell's lab, which we've seen. He did that Mark Rober video and a bunch of other things. And I know he's not the only inventor in there, but are there other things like this? How unusual is this?
So the cool thing about this is that it is using kind of that root technology, the LET joint. Dr. Howell was the main researcher on that, I believe. And then David Morgan in the Industrial Design Group, and Spencer Magleby, who's also part of kind of the Larry Howell Compliant Mechanism group of researchers here on campus. Right. They were able to take that technology and then incorporate it specifically into the industrial design of the furniture that you see here on the podcast. But there's really no limit to what could be done with it. So some of the other applications that they played around with are, and again, the technical kind of term that they're calling it is flexible conformable electronic circuitry. So they're using traditional PCB boards and then adding this joint to give it flexibility.
And PCB boards are the green boards?
Yeah, so the green boards that you would see, if you open up the back of your computer, there's going to be a bunch of PCBs in there or any really kind of electronic. So they introduce this geometry that then allows it to bend in a defined and reliable way. And so kind of use cases could be you have maybe a complex form to an electronic that you want to use, but you don't want to go the really high cost route of flexible circuitry as it's kind of being done now, cutting edge. You want to use like a traditional PCB. So you'd have the PCB, you'd introduce this to get the motion that you want, and then you could then put that into your electronics and have it kind of form fit without introducing a lot of cost.
Okay, so that's kind of, that I assume is kind of a high-end use. It would be, it's really small, probably a more expensive application. But right now we're sitting on chairs made out of the LET joints. There's this furniture over here. So the simple, kind of the first product is probably foldable furniture or something large, right?
Yeah. If I were to acquire this technology, right, kind of my first thing would be, okay, how do I get this to market quickly and cheaply? And the furniture here, we have all the files, right? We already have done the programming on the CNC mill. And so literally you could license the technology and within, a couple of weeks have product ready to be shipped through your distribution channel of choice, right? Whether it's Amazon, Shopify, your own website, you want to go knock doors and sell furniture, right? You could probably do that as well. But that would be kind of the initial technological kind of opportunity that I would want to take with this technology, just because it's so readily deployable.
Okay, and when you're thinking of like the first way to get to market with this, what you would do as an entrepreneur, to me it looks like IKEA furniture. Like it's ultra efficient to ship this, right? You could have one board with all these cuts in it. It's not assembled. then you get it to your college apartment and you fold it up into a chair or something.
Yeah, exactly. And so you could order this in through either overseas manufacturing or find somebody local who has a CNC router. Most of the companies, again, this is me spitballing off the top of my head, but I would go to a company and say, hey, you have the CNC router, you're only running 8 hours a day, let me come in kind of during your downtime and run this right continuously through the night or something, and then I could have product ready to go. And then pack in as many different types of products so that I could utilize that sheet as efficiently as possible. Because you could do a chair with like a nightstand, with some shelving, with potentially a light fixture, right? And then sell that as a kit, or just manufacture it that way so that you got the most out of that material every single time you ran.
Okay, and this is because of your like prototyping manufacturing background.
Yes.
You're thinking don't waste any of the sheet of wood, right?
Ideal situation would be that when it comes off the CNC, there's no scrap, right?
Yeah.
You just have sawdust and then good parts. That would be ideal. Probably not perfectly achievable, but as close to that as you could get would be great.
Okay. So I'm not an engineer and not super technical, but I kind of feel like you wouldn't have to have technical skills. You could license this technology and do a little business just like that.
Yeah, and so initially that would be kind of my first step if I were to license this technology, would be to go exactly with what I feel like is a good market fit. Like you said, the IKEA furniture, IKEA doesn't seem to be hurting for business, so I'd want to be either a direct competitor or semi-direct competitor there, but then also understand that because I have access to the foundational technology, I could either sub-license the technology out to maybe a PCB manufacturer who wants to compete with some of the more high-end flexible circuitry, right? They could do this a little bit cheaper, access that market, or as revenue starts coming in, look at ways to diversify my offering into other markets, right? So looking at the electronics, looking at really anything, roll-up shades, right? Something you could put this geometry into those shades into a single piece of maybe metal material, and then you could have a roll-up shade, right? So things like that, I'd look to extend the use of the technology that I have access to after kind of proving the concept in one market. Okay,
so we've been thinking about that piece of wood and is it PCBs, the electronics boards?
Printed circuit boards, yeah.
So what other materials could you use this with? So those cuts, I was talking to one of the student inventors, and they said they had experimented with all these different variations of the cuts. When people invent something, you don't think about, it's like Thomas Edison, the 100 light bulbs that didn't work.
Yes.
But they definitely have that with this design, and they arrived at the one that we actually filed the patent application. Is there an issued patent?
Yes, so there's actually three issued patents with this technology specifically, kind of different fields of use, but the foundational technology being that LET joint is an issued patent for us. And so with any kind of prototyping, like you've got a couple prototypes over there, I believe this was actually one of the first prototypes that they did in the wood, and you can see like, I don't really want to go much more than that, or else I'm worried that I might start breaking things. But changing the geometry, right, you can then dial in how much flexibility that you want. Obviously, the chair legs.
Yeah, the chairs are like 90 degrees.
Exactly. So really it just comes down to what is your specific use case, what is your material, a little bit of trial and error, right? The nice thing with having some of the research is that you could reference all the published papers. You could get in contact with graduate students. Some of the professors here ask them questions about, hey, how would you approach this? And then very quickly be able to dial into something that works for your specific use case, works for your material, and then is scalable. And that's what I love about this technology is that a lot of your traditional manufacturing techniques, you're going to start out with a piece of sheet material, right?
Yeah.
Either sheet or plate or something of that nature. And so you can go from that directly to a semi-finished product, right? Basically paint it, ship it, and you're good to go. And so your supply chain, the complexity of that supply chain, the complexity of your product itself drops substantially, which means more cost savings for you, better profit margin, and it makes it easier to scale as well.
Okay. So I was going to ask what other materials you can use this in. So obviously plastic as well. I have a plastic piece here. The what other things could you do this with, metal or some?
Yeah, so you'd be able to do it with metal. I know with not this one specifically, but with some of the other compliant mechanism research, they've done things in metal, 3D printed metal. So you could do metal, plastic, sheet metal, wood, obviously, right? We're sitting on that. I'm trying to think of what else off the top of my head.
And for a new entrepreneur, if you're say you're a student entrepreneur, this is your first company you're doing, what's the cheapest material to start with? Would it be wood or plastic?
Probably wood, right?
Okay.
So you'd probably go in and get your OSB sheets from your local supplier, right? They're a little pricey right now, but you could probably get it for around $100, right? Just kind of based off of historically what they've been priced. And so you could sell this, $150, have a $50 margin, more or less, right, once you take into paint. But you could expand out the complexity of the parts and maybe do something in plastic, do something a little bit higher end, a little bit more complex. Obviously, you're going to have benefits and limitations depending on what material you use. Plastic is probably going to be a little bit more forgiving, especially if you use the right kind of plastic. Whereas wood, if you don't get the geometry quite right, you might have some failures and you might have to iterate a couple times to get it to work for you.
Okay, so if I were just starting a new company, let's just talk through the least complicated way of doing this.
Okay.
So say I'm a student entrepreneur. I'll take something that I don't want to figure out geometries or anything. I'm going to use something that already exists. The chair you're sitting on obviously exists. So I'm doing that exact chair. I'm going to sell it, say, online and ship it to people. So what are the steps? What would I have to do? So first, license rights from BYU, right?
Yeah, exactly. So first you'd come and talk to us, right? Talk to me specifically in the BYU Tech Transfer Office. We would come up with a licensing agreement that makes sense for both parties. You would then have access to the technology, and with that, we would probably give you all of the files for everything that you see here so that you would have the pre-programmed files that you could hand off to a CNC router manufacturer. You would locate a manufacturer. I have a couple in mind that I could give you some suggestions for, right? Where you could go to them directly, negotiate a price with them that you would pay per unit piece, right?
So you'll know people who are like manufacturers here in Utah Valley, but or in Utah generally. What if someone in Nebraska is doing this? How hard is it to find a person?
Super easy, right? So most of your like cabinet shops, they're probably going to have a CNC router.
Okay.
Anybody who does like barn doors, they're going to have a CNC router. Pretty much if they do wood, any kind of semi-complex woodworking, they're probably going to have a CNC router. And then again, like trying to put myself in the shoes of a student entrepreneur, I would want to do this as cheaply as possible. So I probably don't want to buy one or rent out the entire facility for a period of time. But I would look to find those kind of entrepreneurial minded business owners who might be willing to work with you and say, hey, you can come in after hours, right? We'll train you on the equipment. And then as long as you just run the same program over and over again, which is another great thing, right? You would basically load a sheet of material, hit go, it would run the program, offload the good parts, unload another sheet of material, and just run and just do that basically all night long.
What if I'm doing like, I don't know, Shopify or Etsy or selling somehow online? Can I take orders? Could I do it like print on demand? How hard would it be to take an order, then create it and ship it?
So pretty easy, actually. So depending on, you might have to do a little bit of prep, right? So you might have to section the plywood into appropriate sections so that you have, like the shelving is a certain size versus the chair, which is a certain size versus the end table. But once you did that, and you could do that with a simple panel saw, right? When somebody places an order, you would then throw it on, select the correct program, hit go, it would cut it out. They could select the finishing options, right? If they wanted any kind of embossing, you could paint their name on it or whatever.
Sure.
Take it off the CNC, paint it, finish it. It's going to flat pack, which is great for shipping, right? So flat pack it, ship it to the customer, and you're good to go. Okay.
Yeah, and so, I'm thinking a few $100s of inventory of wood on hand.
Yeah.
And then you wait for the order to come in, you have it made, and you ship it.
Yeah, and I would go, a bundle of wood at a time. So it might be like $1,000 for that first bundle, maybe a little bit more depending on where you source it from. But having that sitting there, and then when you get, good Kanban system, you get about halfway, bring in your next one. So really, if you were smart and went in really low cost, you could probably be profitable within your first, 100 units, and then use those profits to basically scale up the business, right? Then you can focus on marketing, trying to expand and reach your target audience, potentially expanding where you're offering it. Maybe you start on Etsy and then you go to Shopify, then you want to do something on Amazon, right? All those types of things would be available. And again, if it's generating revenue, generating profit, really your initial investment would be that initial bunk of material.
Right. And which do you think is a more appealing product without doing market research, bookshelf or chairs? Which would you go with?
I would probably do the chairs to start, just because it's ubiquitous. Everybody has a chair. Not everybody's going to want a bookshelf.
Okay.
But I say that, and then I kind of want to change my mind because this is almost a simpler product. It looks more complex, right? But the shelves could all be cut out with the panel saw, and then the actual shelving, you could probably get both of those shelves, maybe not both of them, but at least one out of a piece of, typical plywood material that you could order in. So that might actually be the better first play.
Okay.
Very simple, not a lot of complexity. It self-assembles, right? So it holds itself up once you put all the shelves in. Whereas these actually have a little bit of 3D printing for some components to actually lock things in place. So
a little extra work.
Change my mind. Start with this one, and then I'd probably do the chairs. Actually, I'd probably start here, end tables, and then the chairs.
Okay.
And obviously it depends on interest,
Yeah, with using the LET joint, is the bookshelf itself in materials going to cost more or less than a traditional bookshelf, do you think?
Probably much less would be my guess, right? Because not only are you saving costs on the manufacturing, but also the assembly. Like there's no bolts, there's no metal components here, right? If you've ever assembled an IKEA furniture, not going to knock on IKEA at all, right? But there's a million little bolts and little things. You got to insert, J into K and then find L and then twist it tight. This self-assembles, right? We set it up just an hour ago. It took 5 minutes, right? Zero complexity associated with it.
Okay, so that would be a good first thing. So to go through the steps again, if a student wanted to do this as a startup, or anyone, doesn't have to be a student, you license the technology from BYU, you'll be given designs by BYU.
Yes.
Then you need to contact a CNC router owner.
Yes.
So
anybody who does wood manufacturing was likely candidate of owning a CNC router.
Okay, so work out some deal with them. What would they charge you, do you think?
They'll probably charge you per hour, right? And so that would be something to take into account, but I would imagine shop rates are typically like $135 an hour type of thing, and so something around there.
Okay. So
if I had to just throw out a number.
Yeah, not too bad, especially if you're doing several products at a time.
Yeah, especially if you could get a couple of these off in an hour, right? So, $135 an hour, maybe you can get 10 of these off, right? 10-minute cycle time. You'd have to look at all that, right? Without looking at the details.
Yeah, run a business, you got to figure out the business details. Yeah. But and as part of the business details, you'd have to have distribution and then some kind of marketing, let people know your product exists.
Yeah, exactly.
And that does seem like the entire business, doesn't it?
Yeah, that's pretty much it, right? And then once you start getting some sales, it's all about just scaling, right? And super scalable, like I said. You could bring in 1 bucket of material at a time, start scaling up, bring in 10 at a time, right? Start getting costing discounts, right? Improving your margin. And then I am not a marketing expert by any stretch of the imagination, but it's not hard to see something like this becoming trendy, right? If you can have the right marketing approach, and then all of a sudden your orders shoot through the roof, right? And you're struggling to keep up. Great problem to have.
Yeah, I see ads for things online that are comparable to this on Twitter or wherever else. So
And the price point of it, right? It's not a $10,000 purchase. It's probably not even a $1,000 purchase. Somewhere $100 to $500 range would be my guess as far as a price point.
For furniture.
Super manageable for most people, especially when you're looking at shelving online, right? It's going to cost you, and we just purchased some shelves at home, and it was like $300 for some dinky little shelving unit,
Yeah, and this is a little bit stylish too. Like someone who has kind of style design sense could create some variations of the furniture that would probably appeal to people.
Yeah, absolutely.
So, okay, so that seems like entry level. If someone wanted to take on something, maybe I'm not quite up to computer circuitry yet, but are there some intermediary applications that make sense?
Yeah, so I mentioned kind of that rolling shade, and I haven't really given it a tremendous amount of thought, but I would think something similar to that where maybe you have, I don't know, some kind of metal screen, right, a grate covering, and you could have a retractable kind of metal grating using this technology. So specific use case, not 100% sure yet, but that is kind of one application of a rolling kind of sheet of material.
Well, what about like storefronts you see, mostly in other countries, but maybe in major cities, where you pull down the metal sheet in front of the shop?
There you go.
And it's this jointed sheet of metal. I bet there are tons of components in that. Here it could be one piece.
Exactly. So one piece of material, so you could basically undercut the competition there as far as price, probably actually improve the quality, right? Because you have less failure points. Exactly. And then, the same amount of security, if not better, right? So that would be a great use case for it.
Okay. Pretty interesting. In terms of, so are there any trade-offs? So these materials are flexible because of the LAT joint. How many times can you bend it back and forth before you run into problems?
Yeah, so this is part of the research that happens here at BYU, because obviously, if you're stressing that joint over and over and over, you're worried about fatigue. And the nice thing is that with the correct design choices, you can either have a very reliable failure, so you'll say, after 1 million cycles, it's going to fail. Or you can design it such that the stresses in the material are low enough, especially like in steel, talking about different materials, that you never cross that fatigue threshold. And so you have basically infinite life of the product.
Okay.
So it's a hard question to answer precisely without knowing the exact use case. But, here, that's probably never going to fail because you're going to set it up once, right? You might take it down and set it up when you move, maybe do that a couple times in the life of the product. But as long as you can handle 10 to 20 cycles, you're probably good there. For kind of the rolling security gate, maybe you're going to do that every single day. But if it's made out of steel and you design it correctly, you can make sure that it has an infinite fatigue life.
Okay.
So,
I know our researchers look into that issue. That's why I ask.
Yeah.
But this is in the same class as mechanisms as flip tops on shampoo bottles.
Yes.
I've never had one of those wear out. Right. So
and that's another example. So I took Dr. Howell's class when I was a student here, and he actually talks about, I don't know if it's shampoo bottles specifically, but those flip tops.
Yeah.
And they're designed using polypropylene, if I remember correctly, and designed in such a way that they have an infinite fatigue life. So they're never going to fail just by using it appropriately. Obviously, if you start wrenching on it and pulling on it, it'll probably fail. But using it correctly should have infinite life.
Okay. I got to say, I think with the metal pull-down sheets, I think we came up with a pretty good application right there.
Right, on the spot,
I'd like to see someone do that. Yeah, that seems like a huge financial savings. And in tech transfer, people always say it's kind of a truism for people in our field that tech transfer is solutions in search of problems. And in this case, there's some obvious solutions, obvious problems that can be solved by this solution, like the ones we've mentioned. But there have got to be others, and there's room for, I think the best entrepreneurs come in and see it and see some unique application. So some people hopefully are going to listen to this and say, oh, what they don't realize is that'd be really helpful in whatever area.
And that's honestly kind of the goal of trying to make this a little bit more visible, because obviously the researchers here have moved in a particular direction, right? And I think it's fantastic. Really love the furniture here. But that doesn't mean that there's not a better use case in an industry that maybe we're just not aware of, right? That has a problem that this would be a fantastic solution for, right? And so if anybody sees that, right, we definitely want you to reach out, get in contact with us, and hopefully come up with a licensing agreement that works for you.
Okay, great. And one more question, just because I'm curious. We were talking about the electronic components, making those bendable. When is that most important? Like, what devices are bendable? I mean, you do have phones that bend now, but where would that be a big issue?
So in the news recently, I don't know if you've seen the Las Vegas Sphere. I think that's what they're calling
I've seen it in person, right. That's amazing.
And so if you're thinking about that from kind of the engineering manufacturing perspective, and this is just me kind of like assuming, right? So there's going to be a lot of assumptions in this next statement, but I assume that all of those panels are curved in some sort of way. And anywhere where the material would fail, right, they probably had to add either a joint or a wired connection soldered between two boards, right? And so I'm assuming that if they had had access to this technology, you could have designed those PCBs in a way that they could have flexed when they go into that final circuitry, so that they can have an all uniform kind of curved shape to them. So something like that is a example of an application where you might want that curvature. It's honestly probably not the best solution for something that's going to like fold completely. But I say that with a grain of salt, because with the correct geometry, right, you could probably get it to do that, no problem, no risk of failure.
Okay. Yeah, electronics are designed for like a square rectangular world, right? I was just watching this show about
are they designed for a square rectangular world, or has that been traditionally how the PCBs had to be designed, right? So everything became square and rectangular.
Yeah, that's what I'm saying. And that's not natural. Like cars are curved. Like there are all kinds of places where we want things to be curved.
So if you can add that circuitry in at a fairly low cost, because the PCB, it really wouldn't increase the cost of it because you're just adding some holes, right? Maybe, well, maybe a little bit because you have to cut out the holes. But you could use that traditional manufacturing technique and then accommodate more curved, more ergonomic type of designs. So absolutely.
Okay. Well, great. Well, thanks for talking about the LT joint a bit. This is a very productive lab that has produced this technology. Can you take just 2 minutes and tell us other things that have come out of this lab? There are some related technologies.
Yeah, so some of the related technologies to the LET joint, and we didn't have any examples today, but there's a lattice hinged strainer, right? So it uses the same LET joint, and essentially it's a flat sheet of material with this geometry carved into it, and then as you load it with materials, so think you're washing off your apples, right? You load your apples into it, and it'll sag down and basically create a colander that you can then rinse everything out, right? Pull it out, and then it folds flat so you can slide it into your drawer, right? So
that's cool.
That one's probably the most directly related. Obviously, compliant mechanisms in general. There was just the huge Mark Rober video, right? And so the world's smallest Nerf gun, we were part of that here at BYU, specifically Dr. Howell and his research group, Spencer Magleby, some of the other professors here. Obviously not directly related to the LET joint, but related in the form of compliant mechanisms.
Sort of thing. And then there was also the what's the type of surgery where they put the tube in you?
Laparoscopic.
Laparoscopic, thank you. Yeah, so there's the Bloom Surgical is a student startup that has a little windshield wiper for those.
Yes.
So you don't have to take them out to clean them.
So compliant mechanism there. We also have some, I think they call them Oriceps, which are like origami-inspired forceps for use in laparoscopic surgery. There's a whole bunch of stuff, right? Like to try to name them all off the top of my head, I probably wouldn't be able to do. But if you do have an interest in kind of those compliant mechanism type of worlds, if you've seen it at BYU and it's not licensed to somebody else, more than happy to have that conversation with you and discuss kind of where it's at and if it's available for licensing.
Yeah, and when you're thinking of possible pain points, we've talked about manufacturing expense, how you don't have to have all these joints, so it's cheaper to manufacture, cheaper to ship. but also just storage. When you're talking about things in the kitchen, just taking up less space with
absolutely
big bowls or something, just having things flat is another huge benefit.
Even the
right?
colander example, right? Like everybody knows where the colander is because it's probably sitting in a different bowl somewhere else, hopefully on the top if you need it. If not, you got to take everything out and find it. Whereas this, folds flat, slides into a drawer. You could put it in the same drawer that you have all your cutlery in, right? Just underneath where your forks and spoons and knives are, something like that. So it saves a ton of space.
Yeah. So someone's going to see this episode, become interested in the technology, and reach out to you to discuss how to license it. What do you want from a licensee? Who's the ideal person for you to work with?
So honestly, we're open to working with anybody. I mean, you know that probably better than I do, being here a little bit longer, a lot longer, let's be honest. But the ideal kind of candidate for that is just somebody who kind of catches the vision of the technology, easy to work with, right? Has a good path to success, right? They understand the steps that they need to take, and ideally would have a good team, right? If it's a single individual, it can be really hard to start a company, right? Even with something as simple and as far along in the product development as what we have here. But it'd be great to have a team of individuals who are like-minded, who see the vision here, who have maybe disparate skills, right? Somebody who's engineering focused, somebody who's marketing focused, somebody who's business, finance. You can go get funding if this starts taking off. You can then get some funding to scale. It's always great to see a group or a team of individuals who see the vision and are interested in licensing. Yeah.
No, that's right. Like we're willing to work with anyone who will be enthusiastic, but also different technologies, different products have kind of a different business profile. There's some technologies where you need to know a lot of business and just a little bit of science. This seems like a good one for, we often have, say, engineering students who are very technically savvy, but maybe have not done business before. The business side of this one seems like not rocket science, like maybe being slightly technical would be the thing.
So, from that perspective, definitely, if you were doing it, solo entrepreneur, business-minded, right? Because again, we're going to hand you the files. We're going to kind of walk you through some of the steps, especially if you're here locally. We can probably point you in the right direction to find those connections. And so if you have the business marketing understanding, right, the product side of it is simple enough that without a technical co-founder, you would probably be just fine, especially in this use case.
Okay, and just because it came up in the conversation today, I have to ask you, is there any kind of, have you thought of any kind of humanitarian application of this technology?
Humanitarian application?
I haven't, but something that...
I don't know. I think plywood is kind of ubiquitous around the world, right? And so if you had a way to transform plywood in places where it's already readily available into something that is a little bit nicer, I don't know how many bookshelves they need in a humanitarian crisis.
Well, something, they need something.
Right, but that's just one use case, right?
Well, what about shelters?
Shelters, right. Like there's a lot of different... This is where the creativity of more people than just myself is really important, right? So the purpose of this conversation and getting the technology out there is that more people are going to see this, and somebody who knows more than I do about humanitarian aid or what's needed in these situations is going to see this technology and say, hey, that is a great solution for this specific problem. And so BYU is very friendly to those types of efforts, right? Anything humanitarian focused, we do a lot of humanitarian focused research here at the university, so I'm sure we would be open to discussing the potential licensing there.
Yeah, and I think one thing that was key that you said is that you could use this technology on whatever material you have locally. So instead of creating everything in, I don't know, Norway, wherever you're making stuff, and shipping it to the whole world, you can just maybe more easily manufacture this locally with this technology, possibly. Depends.
No, absolutely, and especially when it comes to scaling your business, right? Kind of circling back to kind of that original entrepreneur use case scenario, you could have localized manufacturers across the U.S. or across the world for this type of stuff, shorten your lead times, right? You don't have to do it. There's no specialized equipment for this, right? It's, in this case, plywood, whatever material you're using, some way to put the geometry into that material, right? And then you're good to go. So you could partner with as many different individuals who are open to doing that manufacturing for you as makes sense for your business.
I mean, the secret sauce really is the way of cutting the joint.
Yes.
So that means everything else is kind of negotiable.
And that's what's really cool about this technology is that the root technology is patented, right? So any variation on the LET joint would be covered in that patent, right? And then you could pursue other kind of IP strategies, trademarks. You could design patents, right? Things of that nature to even more secure your ideas and your designs from the competition.
Yeah, that's great. So this is the first time we've been doing a podcast for a while now. This is the first time we've done an episode about a technology, and the first time we've done video as well. And I think the reason is because this is a very visual technology, something that people should be able to to understand pretty easily, and a good opportunity for just about any entrepreneur who's motivated. Is that fair?
I think so, yeah.
Okay. All right. Well, thanks, Bennett. That's great. The LAT joint, Bennett's your guy to reach out to for that, and appreciate you talking about it.
Okay, thanks, Dave.
Yeah, thanks.